Hi everybody, Mr. Owens here. We're going to go over our new lesson of constructing triangles. So for this lesson, make sure you're taking notes and you're writing everything down. There's some vocabulary. And make sure you're emailing me if you have any questions, okay? Email me if you have any questions when we're done with this. So the first type of triangle we're going to learn about is called an acute triangle. And if you remember, acute angles are angles less than 90 degrees. So this means it's a triangle where every angle is less than 90 degrees. Okay, so if you look at this triangle I made, it has three angles that are all 60 degrees. So all the angles are less than 90. The second type of triangle you need to know about is called an obtuse triangle. So if you remember, an obtuse angle means it is greater than 90 degrees, bigger than 90 degrees. And because we know for triangles, the angles must add up to 180 degrees with the triangle sum theorem, that means only one of the angles will be obtuse, right? Because you can't have two things bigger than 90 and have it still add up to 180. So here's an example of what we're talking about, an obtuse triangle, and this is the obtuse angle, right? Bigger than 90 degrees. So 130 degrees, that's an obtuse triangle. And then finally, really, really important type of triangle called a right triangle. And that means that it has one right angle, which is exactly 90 degrees. Remember, we show 90 degrees with this little box right here. Okay, so this is what a right triangle looks like. It looks like there's an L shape or a backwards L. Okay, so those are three types of triangles you'll need to know based on the angles. Now, after that, we're going to be talking about triangles based on their side lengths. So the first type of triangle based on their side lengths is called an equilateral triangle. And this means that all three sides are equal, the exact same side length. So that's what it looks like this. And we use these little, tick marks, like the little lines, to represent that they are equal. So if like one tick mark means that it is equal to anything else that has one tick mark on it, one little line. The next type of triangle, fun word to say, is called an isosceles triangle. Isosceles triangle. And it means two sides of the triangle are equal. So you might notice two sides have that little line that means they're equal. And then this side, it have two lines to show that it is different than those other sides, okay? So two sides of the triangle are at equal length, are the same length. And then finally, we have the last type of triangle, which is called a scalene triangle, which means that all three side lengths are different, right? There's 1, 2, and then 3 to show that they're all different, okay? A scalene triangle. Okay, so these are our three triangles based on side lengths: equilateral, isosceles, and scalene. And then here are three triangles based on our angles: acute, obtuse, and right. All right. Next, we're going to be going over the triangle inequality theorem. And this is about what the length of the sides can be for a triangle. And what this says is the sum of any two sides of a triangle must be greater than the third side length, okay? The sum of any two side lengths of a triangle must be greater than the third side length. If it is not greater, then it is not a triangle. So here's an example I wanted to talk about. Let's say you have a triangle here where the side lengths are 4, 5, and 7. So you would ask yourself, okay, what's 4 plus 5? That's 9. Is 9 bigger than 7? Yes. Okay, good. What if we did 5 plus 4? That equals 9. Is 9 bigger than 7? Yes. Now what if we did, we can test out more side lengths. We did like 4 plus 7. That's 11. Is 11 bigger than 5, the remaining side length? Yes. What about 5 plus 7? That equals 12. Is 12 bigger than 5, the remaining side length? Yes. Right? And you can keep doing this for all the side lengths just to check. But really, the shortcut is to take the two smallest side lengths, add them up, and see if they're bigger than the third side length, okay? So let's show you a non-example here. Here we have a triangle that is, the side lengths are 2, 3, and 6. So we could say, take the two smallest side lengths, right, 2 and 3, and say, is the sum bigger than 6? So 2 plus 3 is 5. Is 5 bigger than 6? No. So that means this is not a triangle. Not a triangle. And it would end up looking like this, where the side lengths don't quite connect. You want them to go a little bit farther so that they connect, right? But they're not going to connect. So just a reminder, the triangle inequality theorem says that the sum of any two sides of a triangle must be bigger than the third side, okay? So, and now here's a final problem where it's asking you, well, what could a possible side length be, right? So here we have 3 and 5. And we know that whatever the side length is, it must mean that the sum of any two sides is greater than the third side. So we can say, if x is the biggest, if x is the biggest, right? So, oh, sorry, I'm thinking about this wrong. So x actually is not going to be the biggest here. So x is going to be the second largest side length. And so we know that something plus 3 must be greater than 5, okay? So here it's just solving the inequality, right? It's solving the inequality like the equation that you already know how to do. How do you undo plus 3? You minus 3, right? So these cancel out. So we have x must be greater than 2. Okay, so x has to be bigger than 2. And we can do this the other way. X plus 3, or if x plus 3 is less than 5. Oh, sorry, not x plus 3, sorry. It should be 5 plus, I'm not thinking. I'm doing this Monday morning. My Monday morning brain is still not working. So what if x is the biggest size, right? So 5 plus 3 must be, right, bigger than x. So what's 3 plus 5? That's 8. Okay, so we know that x has to be bigger than 2, or x must be less than 8. So the way you can write this is 2 is less than x is less than 8. So that means x is somewhere in between. X is somewhere in between 2, it's bigger than 2, and smaller than 8. So we know, so it's going to be anything that's bigger than 2 and smaller than 8. So it's a little confusing, right? So this part is like if x is the biggest side, and this is like if 5 is the biggest side. Okay, it's a little confusing. So, but what you're doing is you're setting up the inequalities. And that, I think that's mostly all the types of problems you'll see in Edgenuity. If you need any help, please email me or come to my office hours with my normal Zoom link. My email is kowens@jeffersonesd.org. And just email me if you need any help or if you need my Zoom link, okay?